Hi, I'm Aki, and welcome back to another episode of the Advanced Building Tutorial Series. This episode is going to be about advanced things you can do with WorldEdit. A lot of the topics that we're going to talk about today are going to be related to high school mathematics. We're going to start with some WorldEdit expressions, then we're going to move on to the Deform command. After that, we're going to take a look at the Generate command and noise functions. So the first part of this video isn't going to be really useful for building, but it is going to be really useful to understand what we're going to do later on with the Generate command. So like I just said, we're going to look at some expressions or arguments. Now, we've already used arguments without really knowing about it. Say, when we would flatten out terrain and you use replace !0, that's an expression right there. You're telling it to replace everything that is not 0. We're going to go a little bit more into that now. We got our selection here, and we're going to type / replace equals, just like say in Microsoft Excel, an equals indicates the start of a function or the start of an argument. Y equals 20 and 1 for stone. Now, what does this mean? This means that for every block in our selection, it's going to check if the Y coordinates for that block equals 20. If it does equals 20, then it will return as true. So it will set that block to stone. If it's not on Y equals 20, then it won't place stone. It will leave it as it is. If you think about it, it's pretty similar to doing a normal replace command. If we type, say, replace 3, which is the ID for dirt, 1, which is the ID for stone, it's checking for each block inside our selection if it's dirt or not. If it's not dirt, it leaves it as it is. If it is dirt, then the condition is true, so we set it as stone. A really important little detail: if you're on the newer versions and your server has fast async WorldEdit, every expression has to be written inside brackets, except for the generate command. So as we hit enter and check with F3, we can see over the looking at section, it indicates that this stone is at Y equals 20. What if we now change it to every single block that's below 20? And it does exactly that. We can also do the same thing using the X and Z axis, but nothing happens. That's because our condition was every block that had a Z value below 20, and we're over at coordinates nearing 10 million. So yeah, of course no block in my selection is going to satisfy this condition. So most of the time, this is just useful with Y values. I'll leave a link in the description with a list of all the expressions WorldEdit allows. We can do other stuff too, like this. Say the remainder from dividing the Y value by 3 needs to be 0. So what's this going to do? It's going to go through each Y value and divide it by 3. If the remainder is 0, then it will place a stone block. And if it's not 0, it won't. So on Y equals 3, it will divide 3 by 3. That equals 1. Nothing's left over. So Y equals 3 is going to be fully stone. Then say Y equals 5. If we divide 5 by 3, that's 1, and we got 2 left over. The remainder is not 0, so it's not going to place stone there. Now, if we run this, every 3 blocks, a stone layer is placed. And if we check our F3, they're all multiples of 3. 18, 15, 12, etc. But what if we wanted the layers in, I don't know, Y equals 4, Y equals 7, Y equals 10? Then we simply change the remainder to 1. Then we get 4, 7, and 10. Why? Because 4 divided by 3 is 1, but we have 1 left over. That satisfies our condition. WorldEdit also accepts logical operators. Things like ifs, ands, ors. It's all in the expression list in the description. But we're mainly going to focus on ands and ors. So we can do replace equals, and then just like you use parentheses in a calculator to separate different operations, you can do the same thing here. And it's also really useful to separate your function or your expression in like compartments that make it easier to visualize. The Y values that are greater or equal than 5 and the Y values that are less than 10. We're going to replace that with stone. This means that everything above Y equals 5, including Y equals 5, and everything below Y equals 10, all blocks that satisfy both conditions are going to be replaced with stone. And as we hit enter, it does just that. Notice how this goes from Y equals 5 to Y equals 9 and doesn't include Y equals 10. You can assign things to variables in order to make your command a little bit more comprehensible. This is especially useful when you're making long commands and want to keep things organized. Say we do replace equals and our variable name. This can be whatever we want. In this case, I'm going to call it, I don't know, Pedro, and that's going to equal 10. And then y is going to be greater or equal than Pedro, which is our variable. We can even add a +5 there, and then replace all of that with stone. So everything that's above Pedro +5, including Pedro +5, is going to be replaced with stone. Now, my variable here is a number. You can also assign a function to a variable, for example. We'll see examples of this later on. Now we'll move on to the deform command. It is extremely useful to have what we're going to deform inside a perfectly cube selection. We can easily achieve this by making a one block selection and then expanding it by the same amount in every single direction. So there I have a selection that is a perfect cube. The only problem I have with it is that it's too small. So I'll make a bigger one that engulfs the whole house. What makes the deform command so interesting? Well, it allows us to rotate stuff in angles different from 90 degrees, things that we can't do with the rotate command. But before we do that, I need to show you one more thing about expressions. We're going to type /deform. Ignore that -r. I'm going to explain what that is in a few minutes. But we're going to type x plus equals 4. That's going to move our whole house 4 blocks in the positive x direction. And you may be asking, Aki, why didn't you just use /move? That's way easier. And you're right, but my main point here is that these types of expressions are also available to use, and not everything is limited to, say, a static y value. Now let's rotate this thing in weird angles. We're going to type /deform, rotate, and then we'll type in x, Z, and then our angle. The angle has to be in radians. If you don't know what radians angles are, go watch a video about it. So this command is going to leave the x-axis intact, the z-axis intact, and it's going to perform a rotation of pi/4 on the y-axis. And we know that our y-axis is our vertical axis. And it just rotated my house 45 degrees. And there are a few key things to notice here. The first thing we notice is that our house is missing a corner. That's because this command is not like the move command. If your move command extends beyond the region you've selected, no problem, it will move it anyways. The deform command only operates inside the selected region. So we could fix this by expanding our selection. Keep in mind that it has to be a cube. Another issue with this command is that as you get closer to the build, you start to realize it's not actually a perfect rotation. You can find missing blocks, weirdly placed blocks, or missing a window there, and this effect gets amplified the weirder the angle gets. Let's say we wanted a pi/6 rotation. Here we'll have a lot more missing and weird and cursed blocks. And you may be asking yourself, if it messes up the build so much, then why is this useful? Well, to tell you the truth, it's not that useful with buildings because you can use TPLL for that. These weird rotations are really useful when building, say, a cargo ship. Say you're making a port and you want to get some ships on there. So what you do is you go online, you look for their container ships specifications, and you use those measurements to build a straight ship. Once you're done, you can rotate it using deform to the angle that matches the angle of your docks. You quickly go over it, fix everything that was broken during the deform command, and then place the ship in the water. Like this window over here is really weirdly placed. It like ended up inside of the house. Now we'll move on to the star of the show, the generate command. Few things before we start using it. You no longer need to write your expressions in between brackets if you're on the newer versions. So if you have fast async WorldEdit, you don't need to place brackets when writing up the generate command. And you don't need the equal sign before the expression either. Same thing goes for 1.12. You don't need the equal sign anymore. The generate command is executed by typing /generate. It can be cut down to gen and even just g. What is this command used for? Everything. Well, not everything, but you get the point. This command allows us to generate functions, make different shapes, and specifically what we're interested in is mapping noise functions, because we're going to make use of the patterns it generates to make cool gradients. The generate command uses its own coordinate system by default. This is a coordinate system in which this layer ain't gonna be y = 25 anymore. It's gonna be -1. And this layer up here ain't gonna be y = 56 anymore. It's gonna be y = 1. So our coordinates are gonna go from -1 to 1. -1 is gonna be the lowest y value, and 1 is gonna correspond to the highest y value. And the size of your selection isn't going to affect it at all. We'll visualize this in a minute. Same thing goes for the x and z values. This wall right here is facing towards positive x, so this right here is going to be x equals 1 in our new coordinate system. And this right here is going to be x equals minus 1. So if one side is minus 1 and the other side is 1, then what's in between? Well, the center block equals 0, and everything in between is a decimal number between minus 1 and 1. Can I use the normal Minecraft coordinate system for the generate command? Yes, there is a way to choose the coordinate system. We're going to look at it in a minute. Let's visualize this coordinate system. I'm going to generate with white glass all the blocks that satisfy x equals 0, or y equals 0, or z equals 0. Notice how I don't use an equal sign at the start of the expression and don't use any brackets. So that's going to generate the whole x equals 0 plane, the whole y equals 0 plane, and the whole z equals 0 plane. And that's going to allow us to visualize the planes. This right here is going to be y equals 0. Everything in this plane has a y component of 0. This plane right here has an x component that equals 0. And this plane right here has a z component that equals 0. What if we do the same thing for when our coordinates equal 1, but with red glass? And there it generates where the y values equal 1, where the x values equal 1, and where the z values equals 1. And let's do the same with minus 1. This means that when working with generate, we're not going to do y equals 5 anymore, because y is never going to equal 5, because our coordinate system goes from minus 1 to 1, unless we specify another coordinate system. But before we do that, we're going to look at generating some shapes. If you ever had quadratic surfaces in maths, maybe you've seen it in high school. I got my first glimpse at it in first year of university. The formula x squared plus y squared plus z squared equals radius squared may ring a bell for you, because that's the formula for a hollow sphere. I'm going to change that last equal sign to a less than to make it a solid sphere. Oh, and I forgot we need to specify a block as well. So we're telling it to create a hollow sphere out of white concrete, and just as advertised, it generated a sphere. Now, notice how it's not touching the walls of my selection. That's because we said we wanted x squared times y squared times z squared. We wanted all of that to be less than 1. And keep in mind that the radius is squared. So the radius is 1 and it has to be less than that. And the walls of our selection are also 1 because the coordinates go from minus 1 to 1. So that's why it's not touching the selection. And what if we change the radius squared to 0.5? We get a smaller sphere. Now, this is all great, but instead of doing all of this, I could have just done /sphere. Okay, then what about a cylinder? So let's write the equation for it. Instead of doing x times x, I'm going to write it like that, so you know that you can also express powers with WorldEdit. I'm going to change the y to z, so the cylinder is oriented vertically. So when we hit enter, that's exactly what it generates. And you may be thinking, okay bro, but I can also do /cyl to generate a cylinder. Well, yeah, but what about this? It's a donut-shaped cylinder. Okay, if you don't understand what I just typed into that command, there's going to be a picture on screen right now of formulas for quadratic surfaces, and the Wikipedia page for that is going to be in the description. Now, why would you need to generate all of these weird shapes in BTE? If you're doing some weird modern architecture building, or if you're building a stadium that's located in a country that makes a sport out of wasting public funds. Going back to the deform command, remember how we typed in -r and I told you that we were going to see what that did later on? Well, -r means that WorldEdit will use the game's coordinates while executing that command as its coordinate system. -c means that the center of the selection is going to be 0, and then from the center going out, each block is going to equal 1. Meaning that if I have a 31 by 31 selection, for example, the x, y, and z values are going to go from -15 to 15. So it's very similar to the default coordinate system used in the generate command, but instead of going from -1 to 1 and then dividing everything in between to get each block's coordinates, each block is going to be one whole number. There's another one that's -0, but it's the same coordinate system as -c, but instead of using the center of the selection as its 0, it uses the player position as its center. So the block at the player's feet is going to be 0, 0, 0, and then expanding outwards, each block increases each coordinate value by 1. Now to the main point of this video, noise functions. If you're on the newer versions and have fast async WorldEdit, there's a little bit of noise functions included in some commands such as set. But on 1.12, or if you want to customize the noise function, you'll have to use the generate command. The ones that come with the set command and fast async WorldEdit are very simple and are not customizable. But I'm going to talk about what noise functions are first, then I'm going to show you how the fast async WorldEdit exclusive ones work, and then I'm going to show you how you can customize the noise functions, use them on 1.12 or whatever version you want. So noise functions are little functions that we're going to use in our generate commands to generate random patterns. While not technically random, they will seem random. And we can use that to our advantage to generate different patterns and textures that we can later turn into nice gradients. The first noise function is purlin. Purlin has 7 parameters. Its seed, the x value, the y value, the z value, the frequency, the octave, and the persistence. The x, y, and z values, it's the x, y, and z values of the block that it's currently being processed. The first parameter, s, is the seed. Just like the Minecraft seed, it's the seed of the pattern that is going to be generated. Now, you can type whatever number you like there. I usually do a 1, 2, 3. To be honest, the only situation where we're going to have to actually keep the seed in mind is when we're superimposing 2 noise functions, making sure that they don't have the same seed. The frequency value tells us how close together each blob is going to be. The noise function is going to generate these kinds of blobs, and the higher the frequency, the closer these blobs are going to be to each other, and also the smaller these blobs are going to be. Octaves indicate how many times the noise function is run before spitting out the result. The lowest value is 1, and you can increase it to add a sharpness to these blobs. So if the octave is a low value, then the blobs are going to be smooth and they're going to look like blobs. If the octave value is high, then those blobs are going to start to look spikier, kind of like sea urchins. Their edges are not going to be smooth. Their edges are going to be rough. And our last parameter is the persistence. The persistence is going to indicate how much weight each octave is going to have. Now, it's kind of hard to understand if I'm just yapping about it, but we're going to get to visual examples in a second. The second noise function is rigid multi. This one doesn't have persistence. Its persistence value is hard-coded at 0.5. So these are the parameters that we're going to be able to control. Each one of them functions exactly as in the purlin function. Rigid multi is the noise function I use the most because it generates nice and soft blobs that I like for texturing. And the last noise function is Voronoi. And this one doesn't have octaves. It's just seed, x, y, z, and the frequency. And before I forget, when we use these noise functions, we have to actually add a condition. We can't just say noise function go and nothing is going to happen, because these functions are going to spit out a value, if I'm not mistaken, between 0 and 1, and that has to go somewhere. We have to do something with that. If we don't, it's just like saying x plus 5. Well, yeah, x plus 5 what? You have to add a greater than or smaller than or an equal or whatever. We have to actually give it a condition. If we don't, it's just going to fill out every single block in our selection. But before going into each noise function, let's go look at those simpler versions that a fast async WorldEdit has. Well, we're here over on the BTE UK server to show you how to use these noise functions with the set command. If you're on 1.12 and you're not interested in how this can be used in newer versions, skip to the timestamp that's on the screen right now. Well, let's get right into it. The first function is simplex, and we can use this by typing #simplex, then the average size of each blob, say 3, and then what blocks are going to be used. Say red and yellow wool, because I hate my eyes. So the 3 value is kind of similar to the frequency, but not exactly. Like I said, these commands are not as customizable as the ones on the generate command. But if we change it to 6, the blobs are bigger. The other noise function you can use is purlin, same parameters, and we hit enter. Up next we have the Voronoi function, and finally the rigid multi function, which we can abbreviate with the letters RMF. Here I have a more complex example of this, and the function involves a purlin function with an average size of 15. The blocks we're going to use are grass blocks, and then another purlin function inside the original one with an average blob size of 6, and for its blocks, another function, this time a Voronoi one, with an average blob size of 6, made out of green concrete powder and moss block. and then corresponding to the purlin function with an average blob size of 6, green concrete. If we hit enter, we get this thing, which is pretty ugly. The green concrete is really off. We could change it, say, to lime terracotta. And experienced BTE builders are probably vomiting all over their keyboards right now. Yeah, this is not a pretty pattern, but it's an example to show how you can combine different noise functions to make patterns. So let's go back to 1.12. Right, we're back. So I've selected an area here on the floor, and we're going to do /G. We're going to use the -C coordinate system. We're going to use red concrete as a block, and we're going to use the rigid multifunction. We're going to use 1 as a seed. We're going to leave X, Y, and Z intact. 0.03 is going to be the frequency, and we'll use 1 for the octaves. All of that has to be less than 0.5. And there's our blobs. Now, because the generate command uses a coordinate system based on our selection, the size of each blob is going to be relative to the size of our selection. So if I make a smaller selection, I'm still going to have these 4 blobs. They're just going to be smaller. Now, what if I didn't want the blobs and I wanted to generate the web that's in between? Well, we can just invert the argument, and if I actually use a different color of concrete, we can generate the web that's in between. There are many applications for these noise functions in BTE. So here we have the generate command. We're going to generate with white concrete of our noise function with 3 as its seed and 0.05 as its frequency. That's going to be stored in a variable called var1. And I'm going to store in var2 the same noise function, but with the added +1 to each of the coordinates. And then as my argument, as my output, I'm going to subtract var2 to vra1 and get the absolute value of that. And this is going to generate a sort of spider web. If we increase the frequency slightly, then the web's density is going to increase. What if I outright delete one of the variables? Then everything gets filled, because like I mentioned a while ago, we have no argument. I'm just running the noise function and putting that in a variable, but I'm not actually doing anything with it. Now, what use does this have? Well, this is a function I use to create patterns on walls. Say you have a warehouse and you made the walls out of diamond block. Then you can apply a G mask for that diamond block, and then I generate that function out of gold blocks. That's going to generate all of that web pattern on my walls. And since it's a bit of an old warehouse, say in this example with walls out of corrugated sheet metal, some of it is bound to be rusted. So I can replace all of the diamond blocks with a gray pattern simulating that metal sheet, and all of the gold blocks, that is all that web shape thing we generated, with brown blocks to simulate rust. You can also superimpose different noise functions, changing their seeds to make other patterns. And we get this weird superimposed web shape. This could be used as a pattern on a roof. Say you have a factory building. The roof is probably going to be a flat surface, usually made out of reflective asphalt membrane. And that membrane, over time, gets these sort of cracks and changes colors in areas where rainwater accumulated. So a thing you could do is replace the matrix, that's the blocks in between. You could set the emerald blocks as your base color, then say the gold grid to a lighter color and diamond grid to a slightly darker color. And that can give a cool pattern, and it actually looks like it's a little bit worn out. Let's move on to some more interesting examples. So we got this command right here, and this one is pretty interesting because it's going to run a rigid multifunction 1.6 as its frequency, 1 octave, and that's going to be multiplied by 15.99. Why are we multiplying it by 15.99? Because we're storing that function in a variable called data. And you might recall from our basic WorldEdit episode at the end where we actually used that variable. That data variable is going to be the block's data value. And if you look at the block we are using to generate this structure, we are using 35. And 35 is wool. So that means that our noise function is actually attached to the wool's data value. For wool, its data value is its color. So the color is going to be linked to whatever the noise function outputs. And as I said earlier, the noise function is going to spit out a value in between 0 and 1. And that's why we're multiplying it by 15.99. When we hit enter, we get something like this. This is extremely useful when you have a parking lot, for example. You want to texture it. On Google Maps, you see there are darker spots and there are lighter spots. using this command, you can generate those spots. And because it's made out of different color wools, it's ready for you to replace each wool color with a block from your gradient. Now, like I said on the construction tips episode, usually you'll mark out your lighter and darker spots based on the imagery from Google Maps or whatever source. And obviously, this generate command, just like that, isn't going to coincide with the darker and lighter spots you see on Google Maps. And this is where your imagination comes in. Not only is the application for this sort of stuff up to you, but it's also up to you to play with the parameters, change the seeds until you reach something that resembles what's on Google Maps. If you don't have 8 or 9 blocks on your gradient, you can change the amount of colored wools to generate. Say like that, you'll get the first 5 colors. You can change the frequency, you can change the octaves. And just like I mentioned before, if you increase the octaves, it looks sharper. Now let's look at another rigid multi example. So we're going to run a noise function, store it in our variable, and then that data value for the wool is going to be that variable times 5. This is really similar to the last example. And it generates these more of like branched out blobs. If we decrease the octaves, it's going to be something smoother. And if we increase the frequency, we're going to have more blobs. This could maybe work like for a seabed or something like that. If we multiply our variable by a higher number, we'll get more wool colors. I personally like smoother textures because you can use smoother textures, say for a parking lot or like an empty lot or for a riverbed, but these sharper textures could actually work, say for a forest. Maybe you want some areas to be muddy, some other areas to have leaves. I'm talking about the forest floor here. Some other area to have grass, some other area to be dirt, and this sharper design, this higher octave design, could actually work for that, since we're gonna have trees placed on top of that, so it doesn't have to be as smooth. The possibilities are really up to each builder's imagination, and having this heat map style texture being generated allows us to quickly and easily replace each section with a block we want. I personally have a lot of fun creating these textures, and usually when I'm bored and don't want to build, I start generating these textures and start changing each parameter, adding noise functions, subtracting them, superimposing them, and when I get to something I like and say, I could use this, I save it to a notepad and start using that pattern later when I'm building. In fact, all of these examples are from that notepad. Let's go over to our last example here, but this time we're using a purlin function instead of rigid multi. The seed is going to be 278 because, I don't know, it just popped into my head. We'll leave X, Y, and Z intact. You can change that if you want to. In fact, I encourage you to change that. So we're going to have our purlin with frequency set to 1, octave set to 1, and persistence set to 1. And again, we're going to multiply that by a number and then store that in the data variable. And to switch things up a bit, I'm going to change this from wool to concrete, and we're gonna hit enter. Now, I've said before that I personally prefer rigid multi over purlin or Voronoi, but each function has its own beauty, and you can actually mitigate some of its downsides by changing the parameters up a bit. But yeah, this is a purlin one. Like I said before, this episode is more of an abstract thing. I'm showing you this thing you can do, and it's up to you to play around with it, find uses for it. I think I gave enough examples. I'm not going to change the parameters on this one, but I am going to show you something before I go. So we're going to select this little small area here, and we're going to run the same command again. And like I mentioned before, because the coordinates are relative to the selection and not to the world, they're not the Minecraft coordinates, no matter the selection size, if we make our selection elsewhere, bigger or smaller, as long as we don't change the seed, you can see we have the exact same pattern. And that's it for this episode. If you made it this far, I really appreciate it. Thank you. Maybe you can add a Subway Surfers gameplay on the side next time so you don't fall asleep. And I promise the next episodes are not going to be as complex as this one. So yeah, I hope it was useful. I hope you learned something new, and I'll see you next time. Bye!